Previously, I've shown how the game loop in Unto Deepest Depths works, but the other big piece of any good strategy game is its units. So today I'll show you how I've structured my game's code so that I can easily support a variety of troops. To understand the technical side of units, let's first briefly look at their feature list. During gameplay, units have two things they can do: move and use an ability. For most units in the game, this ability is just an attack of some sort, but there are some units that have a non-attack ability. For example, healers heal their allies and necromancers summon skeletons to join the fight. Unlike more complex tactical games, each unit only has one ability, so there's no action point considerations or choices that need to be made as to what ability should be used, just the choice of where the ability should be used. Outside of combat, units again have two functions: promotions and upgrades. Promotions are changes to the unit's class that are acquired by spending XP. Each class allows for promoting to certain other classes along an upgrade tree type of system, and as currently implemented in the demo, the promotion tree looks like this, though I have plans for several more units in the full version. The last element of units is upgrades. Upgrades are bonuses and modifications to how units operate. These could be simple things like health increases or damage bonuses against certain types of enemies, or more complex things like death saves or certain bonuses for ending turns next to an ally. The list of upgrades available are the same for every unit, but they are expensive and follow an upgrade tree structure, so choices have to be made as to where and who to upgrade. That's everything a unit needs to be able to do, so now let's look at how I define and manage the data for individual classes and instances of units. At the heart of everything is the unit definition class, which is a custom resource that defines everything unique about a unit. This includes basic things such as the unit's name, type, and a reference to its unique animation frames, along with combat-oriented things like health, allowed movement or attack patterns, information on progression such as upgrades and promotions, and so on. For each unique class in the game, such as a mage or a skeleton, I have pre-made definitions that define what a fresh instance of this unit looks like, such as its starting health, cost to promote, and of course all of the previously mentioned elements of a unit. When a unit is needed in the game, such as when adding one to the player's party, the base instance of that unit is duplicated and used so that I now have a unique copy per unit. For things like promotions, the same thing is done, but I also copy the relevant unique properties, such as any purchased upgrades, from the previous unit definition so that this unit definition is up to date. As far as working with unit definitions, there are multiple places they get used in the game, but most uses just consist of reading and manipulating the definition directly. For instance, to buy an upgrade, I just need to add that upgrade to the list of upgrades on a specific unit's definition. For battles though, things are a little bit more involved, so let's now look at how these get used on the battlefield. Functionally, every unit is the same, so during battle, every unit is represented in the game world by a unit instance, a relatively straightforward Node 2D scene with nodes for the graphics, audio, health bar, and miscellaneous effects, which we'll talk about later. When battle loads, unit instances are created and placed around the map as appropriate and assigned an associated unit definition, which they use to load operational information such as how much health they should have, what sprite frames to use for animation, and so on. This is enough to get the basics in place, as each unit now at least looks correct on screen, but units still need to be able to do stuff on their turn, and that's where two components come into play: Abilities DB and AI Controller. In order to talk about those components though, we first need to talk about how actions work in Unto Deepest Depths. In the unit definition, actions are defined as custom classes that are really just data containers holding a series of relative unit coordinates on what cells will be affected, called the path, an entry for the relative cell that should be clicked on for confirming that action, called the endpoint, and the rule to follow on how to handle objects in the world that overlap with these coordinates, called the block mode. For instance, a unit that can move one cell to the right would have an action with a path of 1, 0 and an endpoint of 1, 0, while a unit that can move two cells to the left would have a path of -1, 0, -2, 0, and an endpoint of -2, 0. As a unit can only move to an open cell, each of these actions will also have a block mode of cancel, indicating that if any cell on the list is occupied by another unit or object in the world, this movement cannot be used. Attacks work the same, though most have different block modes in accordance with the attack type. A melee attack, such as on a knight, will typically have a block mode of ignore, since you should be able to attack regardless of if something is in your way, hopefully an opponent, while the archer, who has a long-range attack that should stop at the first thing it hits, will have a block mode of truncate on, so that the shot only goes as far as it possibly can and then stops. So with actions defined as relative coordinates and rules on how to handle objects in their way, I can now show how to use this information to look at what actions are viable and how to execute them. On a unit's turn, whether for moving or attacking, it first needs to know what actions it can take according to the rules of all possible actions. That's where Abilities DB comes into play. Abilities DB, the name of which is a bit of a holdover from early prototyping days, answers the question, given the current game state, what actions are viable right now? The primary way of answering this question is of course by looking at all possible actions for moving or attacking, turning relative coordinates into absolute, and filtering them according to their block mode and current map and unit positional data. Abilities DB can also handle edge cases related to planning, of which there's currently 2. The first is teleporters, which appear late in the game and zip you around the map. For teleporters, a move action needs to be modified so the final endpoint is wherever you'll end up after teleporting. This lets the player know where they'll go, but also is required so that the AI can plan around the potential usage of teleporters. Abilities DB makes this change internally so that units and their AI only knows they have a list of move options and don't have to worry about the details of how they got there. The other edge case is when there are no viable actions to choose from. It's rare, but it is possible a unit with limited movement or attack options, such as a mage, gets surrounded by other units on their turn and can't go anywhere when it's time to move. Abilities DB checks for this and returns a simple no-op action as a backup so that neither the player nor the AI ever gets soft-locked due to a lack of options. So for those of you hoping you could choose not to have to move or attack every turn, this is the one time in the game you'll have that option. Once the list of actual actions that can be taken has been generated, it's then time to make a decision about what to do. As I've already covered, player units get their actions bubbled up into the UI, whereas the AI just needs to make a decision and act. This decision is made inside the AI controller, a ref-counted instance that takes the list of actions provided by Abilities DB, grabs any relevant world state, such as the position of allies and enemies, and decides upon the best available action at that point in time. I'll talk more about how this decision is made in a later video, but for now just know that it takes the output of Abilities DB, makes a decision on how to act, and returns this data to the unit instance where it then can be acted upon as usual. And that's how actions are handled, but there's one remaining item that you may have noticed that I haven't covered: the unit-specific effects that can be triggered when acting. For instance, the mage shoots a wave of flames around the field, and the healer lights up the unit it's healing. These are implemented via what I call unit type components. These components are custom scenes filled with whatever content that unit needs to support their actions. The key is that each scene inherits from a very minimal class that helps wire events from the parent unit to the component. With these events wired into the component, I can play an animation, sound effect, or even spawn an enemy as part of a unit's attack. Type components also have the option to override the regular enemy attack flow in case I want to have a cooldown or similar on a unit's attack. It is a rare use case, but there is 1 or 2 units in the game that may need it, so I have it here as a method that can be overridden. To use these type components, I just create whatever scene I want, have it inherit from this script, override as necessary, and add an entry to the unit's definition, which takes an array of unit type components. These will get generated and added to the unit instance at runtime and become an extension of that unit. And that's a look at how units are coded in Unto Deepest Depths. There's still a lot more I want to cover on this game, so let me know if you have any questions or things you want to see. If the game interests you, you can go on Steam, which will be linked in the description, and check out the demo and wishlist.